Happy New Year, Algebra kids. We're back at it. Please make sure you are starting this semester off right. Hope you have some notes in front of you and you pick them up at the school, or you are writing these down. Start off fresh. This is a new year, new beginning, so let's go. Let's do this. So let's remind ourselves a little some review. So x plus 3 equals 10. What would I do? What would be the opposite of adding? Well, that would be subtracting, correct? So the opposite of adding is subtracting. Now let's think of a different one, okay? So what if I was multiplying something? Okay, so let's say I had 3x equals 12. Well, how do I do the inverse operation, the opposite? Well, I would divide. So the opposite of multiplying is dividing. All right, so this unit is going to be about the last type of operation. So we don't really talk about them too often, but this unit we definitely will. So let's say I did 5 squared. 5 squared is 25. 5 times 5 is 25. Well, what is the opposite of squaring something? It's actually called square rooting. So square rooting 25 would be 5. Okay? So the opposite of squaring or cubing something is square rooting. Okay? That's the opposite. Okay? So the product when a number is multiplied by itself. Okay? That is called a perfect square. Okay? So exponent is the number of times you need to multiply a number by itself. So if you had 5 to the third, that would mean that you would multiply 5 by itself 3 times. Okay? So 1 squared is 1. 2 squared, again, is 2 times 2, which is 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. Please fill out this chart or write all of these down. Make it organized. You'll be referring back to it the entire unit. So 6 squared is 36. 7 squared, 49. 64, 81, and 100. Again, we're not doing 9 times 2, which is 18. We're doing 9 times 9. And then we'll go on to the next row. 11 squared, 11 times 11 is 121. 144, 169, 196, and then 225, okay? So in your calculators, there should be a little button that looks like x squared. So what you can do is you can type in, like if you had 10 and then x squared, and then hit the equal button, and then it should go to 100 for you. All right, list of perfect cubes. Again, so instead of going squared, meaning you're timesing the number by itself twice, cube means that you're doing it 3 times. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 cubed would be 27. 4 cubed is 64. And 5 cubed is 125. So if you ever have a problem that is asking about exponents, so in your calculator, there should also be a button that looks like this. It's kind of an upside down V. So let's say I wanted to do 5 to the 3. So 5 cubed. What you would put in the calculator is 5, and then the upside down V to the third, and hit the equal button, and then it would show you 125, okay? So you could do that with any of them. You could do 10 to the third. So that would be 10 upside down V to the third, okay? So 10 upside down V to the third, and then you should get 1,000. You can also, again, if your calculator doesn't do that, you could do 10 times 10 times 10. It would give you that same answer. And then one more definition. So a radical is the opposite of an exponent. So like I was saying, so if the exponent is squared, the radical is square root. If the exponent is 5 to the third, the opposite of that is a cube root, and it will have this symbol with the little 3 in it. Okay? All right, awesome. So let's actually evaluate these now. So the square root of 64. So let's look at our list. So let's find 64. 64 is right here. So if 8 squared is 64, the square root of 64 is the opposite, which is 8, because 8, how do I split up 64? So 8 times 8, I have a pair, and if I have a pair, it can come out of the radical, out of the house, okay? Okay, so it's like going on a date when we could do that, okay? You can't go on a date unless there's 2 of you, right? So the same with this one, 36. Well, how do I split that up? Well, 6 and 6, I have a pair, so then it can come out. There's a negative on the outside, so I put the negative in front, okay? Now let's look at this next one. All right, the next one is the square root of -4. So that would be -2 times -2, which would actually equal +4 if it came out of that square root. So what we actually do is a thing called 2i. So that I takes the place of that negative. And we'll talk about that more in the future. But again, for this one, because the negative's on the inside of a square root, your answer is 2i. All right, let's do this next one. So the square root of 400, y to the 4th. Well, how do I get 400? Well, that is 20 times 20, okay? That's your pair to get 400. And then y to the 4th, well, how many pairs do I have? I have a y, a y, a y, and a y. So how many pairs do I have? Well, that means I have one pair of y's and another pair of y's. So I have 2 pairs, y squared. Okay, and then I also have a pair of 20s, so that 20 will come out. So that's my answer, 20y squared. All right, let's go to the next one. So 49, the square root of 49 is 7, and then I'm going to bring down this plus or minus from the front. Okay, the same thing for the next one. What's the square root of 144? That's 12. And then what does x squared mean? That means that there's 2 x's. Well, if there's a pair, I can take it out. So then I have plus or minus 12x. All right, moving right along. So again, looking for pairs because we're talking about square root. Remember, so if I had the square root of 25, that's 5 times 5. That's a pair, so my answer is 5. Okay, why is that the case? Because 5 squared is 25. So we're doing the opposite of an exponent. The square root of 169 is 13, and then I'm going to bring that negative inside to the outside. The square root of 1. Well, that 1 is very unique because anything 1 times 1, you can do 1 to the 10th or 1 to the 1st. All the answers will be the same, which is 1. All right, so now let's move on to the next ones. Evaluate the following radicals. Okay, so I'm just going to focus on those. So the cube root of 64. Okay, so I want pairs of 3. All right. First, I'm going to look at my chart and see if I can find 64. Well, 64 is in 2 places. Actually, 64 is 8 squared, but I'm not looking for squareds. I'm looking for cubes. So that is 64. So 4 to the 3rd is 64. So what does that mean? Well, the cube root of 64 is 4, because 4 times 4 times 4 is 64. So that's why it's the opposite. Okay, the next one, okay, if I don't know what the cube roots of a number is, then I can, again, find groups of 3. So if I have a cube root, we're trying to find groups of 3. And if I have a square root, which there's no number in front if it's square root, I'm trying to find groups of 2. All right, so let's break apart 8. So what numbers go into 8 when we're multiplying, okay? So I know 2 times 4 equals 8, all right? And if I broke apart the 4, that would also be 2 times 2, which equals 4. Well, if you notice, I get a group of 3 because it's a cube root. So if I have a group of 3, they can come out of the radical house and put it right there. And then I have a little cube root right there. All right, x to the 3rd means I have 3 x's. That's also a group of 3. So is that inside or outside the radical house? It is also outside the radical house. So then my final answer would be 3x. Okay? All right, let's try this next one. All right, I have cube root of negative 27. All right, let's break apart 27. So what two numbers multiply to 27? Well, that's 9 times 3. All right, 3 I can't break apart more, but I can break apart the 9 with 3 times 3. And now I have a group of 3. So if I have a group of 3, they can come out of the house and hang out. So now I have 3. All right, and that is my final answer. Why? Oh, wait, hold on. It's a negative, so it would be negative 3 times negative 3 times negative 3, and now my final answer would be negative 3, not positive 3, because of that negative in front. All right, 343. I don't know what goes into 343, so I'm going to just start dividing different numbers. So let's do 343 divided by 4, or 343 divided by 8. Or 343 divided by 7. Okay, so 343 is 7 times 49. Okay, and then 7, I can't break apart 7 more, but can I break apart 49 more? Yes, 7 times 7. Why can I not break apart 7 anymore? Because then it would just be 7 times 1. Okay, it's a prime number. So I stop once I get primes. Now again, I'm trying, it is a cube root. I need a group of 3 in order for them to leave the radical house. All right, so if I have a group of 3, they can leave the radical house and be on the outside. Now let's think x to the 9th. How many x's does that mean? Well, that means 9 x's. So how many groups of 3 is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means 1, 2, 3 groups of 3. So my final answer is 7x to the 3rd. All right. So that's what we have with evaluating the following radicals. Taking them out, and then again, if it's a square root, making groups of 2. If it's a cube root, you're making groups of 3. Careful with your negatives and positives. All right, we're almost there, folks. So approximate the value of the radical by listing the two integers that the radical lies in between. So it's like we're making a number line, and we're trying to figure out, where does the square root of 18, where does it hang out? Okay, based on where the square roots are. Okay, so we're going to look at our list. Look at our list and look to see, I know there's a lot going on this page. So look to see on our list, where would 18 be? Where would that 18 be? So 64, 64. So 18 would be between these two square roots. Okay, it's between 16 and 25. All right, so the square root of 16 and the square root of 25, 18 would be in between those. Well, what is the square root of 16? Well, it would be 4 times 4. That's a group, so that's a pair. So that's 4. And what's the square root of 25? 5. We keep talking about it. So what is the two integers is between? 4 and 5. All right, now let's do the next one. The cube root of 3. So I have a cube root of 1, and then I have the cube root of 8. So the cube root of 3 would be between those two, looking at my chart. So the cube root of 1 is 1, and the cube root of 8 is 2. So this answer would be between 1 and 2. It'd be a decimal in between them. All right? Now the last one, 3, a cube root of negative 15. All right, well, we've got some negatives going on. So the cube root, where would 15 be? Again, let's look at our chart. 15 would be between the 8 and the 27. So the square root of negative 8, or the cube root of negative 8 and the cube root of negative 27. So what is the cube root of negative 8? That would be negative 2. And the cube root of negative 27 would be negative 3. So your answer would be between negative 2 and negative 3. Right? So that's how we approximate. Find the perfect squares that are on either side of this number, and then find the square roots, and then you'll know that the radical lies between those two integers. Okay? Again, we don't want decimals. We're looking for the integers. All right? Same thing on this page. So the cube root of 36, what is that between? All right, so I want you to try G, H, and I and come back and check. All right, so G, you should have gotten 3 and 4 as your integers. H, you should have gotten 3 and 4 also. But again, a cube root is different than a square root, so be careful on that one. And then I wanted to tell you why this is the case. So if I actually put the square root of 76 in the calculator, my answer would be 8.7. But what if you don't have a calculator? And they also want to know where the number would be. Well, what's a square? Well, what is the perfect squares on either side? Well, it's 64 and 81. I looked at my list and saw where would 76 be. Square root of 64 is 8, and the square root of 81 is 9. Well, 8.7 would be between those two numbers. That's what we're trying to do, is tell you what the integers would be on either side, okay? Because your answer would be a decimal. All right, approximate the radical to the nearest integer. So now we're going to actually practice. So now we're actually going to practice putting it into the calculator. So the square root of 23. So the square root of 23 would be 4.7. Okay, so 4.7, and it says round to the nearest integer, so then that would become 5. Okay, 7 is greater than 5, so then that means that I move up the decimal to I move the number up 1. Okay, now let's do the square root of 95. So the square root of 95, well, that is 9.7. Okay, so I'm going to, again, round up to the nearest integer, which would become 10. All right, the very last one, the cube root of 100. Okay, so now we want to use the cube root button. So if you have your calculator, you can use that square root. It is x to the square root. You can put 3 and then enter, and then use that x square root button, and your calculator will change the x to a 3. Okay? You can also do it old school. It should be available on your phones also. If you turn your phone to the side, it should work that way also. So I'm going to put into my calculator, and I get 4.6. So 4.6 would be your answer. So what is that to the nearest integer? That would be 5 for the cube root of 100. All right. So here are a few tricky ones, but again, we're going to plug some numbers in and evaluate. So we're following and evaluating the expressions. All right, so 5 square root x. Well, I'm going to plug this 64 in. So I have 5 times the square root of 64. So the square root of 64, well, that's 8 times 8. So I'm going to bring it out of the radical house, and my answer is 8. Because, 8 times 8, have the pair. I take one out. And then what am I going to do? Well, 5 is multiplied to that. So I'm going to do 5 times 8, which is 40, will be my final answer. So the radical I'm going to do first, and then multiply it to that number. All right, the next one. Again, I'm going to plug 27 in for both of the x's. So the cube root of 27 plus 27. Well, the cube root of 27 is on my list, or you could also do the 9 times 3. 9, what goes into it? 3. 3 times 3. That's my group of 3 because it's cube root. Cube root, I need a group of 3. Take it out of the radical house, which becomes 3. Bring down this plus 27. 3 plus 27 is 30. Okay? All right, the last one, I'm going to plug 9 in and solve. So the square root of 9 times the square root of 9 minus 7. Okay, so what am I going to do? I'm going to deal with the radicals first. So the square root of 9 is 3. The square root of 9 is 3, and then 3 minus 7. And PEMDAS tells me that I need to do parentheses. Well, parentheses and grouping. It's kind of all together. So first I do the radical. Now I'm going to do the parentheses. 3 minus 7 is negative 4. And then bring down the 3 in the front. 3 times negative 4 is negative 12. All right, so that is the end of lesson 1. Please ask questions. Please make sure you're getting this done. And we will see you virtually, or we'll see you in person. Have a great day.